Hey everyone! Today I want to talk about some of the incredible dinosaurs who call Antarctica their home. But before we get to that, I have a problem. Whose bright idea was it to make a video on Antarctica in the dead of winter? It's freezing out here! I feel like my ears are about to fall off. It's so cold! And unlike my new friend over there, I don't have a thick coat of feathers to help insulate me from the— What are you doing? What's it look like I'm doing? I'm trying to tell everyone about my new bestie. You do realize that Antarctica's climate was vastly different 200 million years ago, right? Wait a second, does that mean? Yep, you and your friend don't have to be cold for this video. Yay! Welcome to Antarctica during the early Jurassic period. Now, you've already met my buddy here, and trust me, we'll be making even more exciting new friends here soon. But for those of you who are familiar with my other videos, you might have noticed a striking similarity between this creature and Dilophosaurus. What's going on here? Did dinosaurs have Aloha forms? Not exactly, but believe it or not, despite looking like bizarro versions of the dinosaurs we are already familiar with, when we take a closer look, we start to see that the dinosaurs of Antarctica might actually have less in common with their relatives than we initially thought. And these surprising differences are opening up new avenues of research for paleontologists to gain a better understanding of how different environments influence the evolution of prehistoric animals. To put it simply, if you've ever wondered how we went from this to this, the recent discoveries in Antarctica might help provide us with the missing link. So today, we're taking a look at the dinosaurs of Antarctica and uncovering how these fascinating creatures are reshaping our understanding of dinosaur evolution. Don't forget to hit that like button, and let's dive into this. It's the early Jurassic period, and dinosaurs are going through some pretty big changes. Following the end of the Triassic period, where volcanic eruptions triggered a mass extinction that set the stage for dinosaurs to be one of the planet's most dominant species for the next 150 million years. During this time, the continents of Africa, South America, and Antarctica were all combined into the supercontinent known as Gondwana. Gondwana is interesting because throughout the time of the dinosaurs, it was in the process of breaking apart. This process is interesting because it led to the increased isolation of different species and resulted in some truly unique adaptations among dinosaurs. But for now, let's take a look at Gondwana as it would have looked during the early Jurassic. Here, we can see that portion of land that would eventually break off and form Antarctica is much further up north than it is today. Okay, here comes the part where I state the obvious. I'm supposed to tell you that because Antarctica was further north, that means it was warmer and thus more suitable for dinosaurs to thrive. Only, it wasn't. Sure, it was warmer than today, and with average temperatures around 10 to 20 degrees Celsius, some of you might even say the weather was quite pleasant. But for animals of the early Jurassic period, that's still pretty cold. And to make matters worse, during the winter months, the animals of this region could experience up to 6 months of total darkness. So, survival wasn't the easiest. But before we get to that, there's someone I'm eager for you all to meet. So let me introduce you to Cryolophosaurus, or as his friends call him, Elvisaurus. It's the hairdo. Okay, so we have an animal that sorta looks like Dilophosaurus, but lives in a different region and has a stylish pompadour for a head crest. Pretty straightforward, right? Wrong. What makes Cryolophosaurus so interesting is that it's an evolutionary mosaic of both old and new traits of a similar species, all wrapped up into this fine specimen of a dinosaur. To better explain what I mean by this, let's take a look at the skull of Cryolophosaurus and compare it to the skull of Dilophosaurus. If we just ignore the head crest for a moment, they look pretty similar, right? Both of these animals lived around the same period, and they both had large openings in their skull, which was a trait common in early theropods. This helped to make their skulls lighter and contributed to their increasing size. In addition to their large holes, their skulls also featured long slender snouts and primitive teeth that weren't specialized for shredding or crunching through tough bone. But as always, the devil is in the details. The openings in the skull of Cryolophosaurus were smaller than the ones on Dilophosaurus, and the bone material that made up the skull was also thicker, which means that despite being similar in appearance, the skull of Cryolophosaurus was stronger and more compact. This type of skull is something we see in later theropods such as Allosaurus and Sinraptor, and it would also play an important role in the increased bite forces we see in the later theropods such as T-Rex. But it wasn't just the skull that was different. Remember when I said the early Jurassic was a starting point for dinosaurs to really take off? This was also the point in time where dinosaurs really started to increase their size. And to do that, they would need to eat their vegetables? Ew, gross! No, they needed strong legs to support their larger bodies, which is exactly what we see in Cryolophosaurus. If we look at a cross-section of the leg bones of Cryolophosaurus and then compare it to Dilophosaurus, we can see that the femur bone for Cryolophosaurus is thicker and likely sturdier than that of its cousin. We'll get a little more into this later, but for now, the important thing to understand is that despite being similar in structure to the early theropods, the legs of Cryolophosaurus had features that would later be present in some of its larger cousins. Okay, the time has come to finally talk about its amazing ankles. They were also more developed. Speaking of ankles, who's ready to talk about an Ankylosaurus? Let me introduce you to the armored tank of Antarctica, Antarctopelta. This animal was the first dinosaur to be discovered in Antarctica. In 1986, a group of geologists led by Eduardo Alvaro made their way up to James Ross Island, located at the tip of the Antarctic Peninsula. The purpose of the trip was to study the geological history of the continent and help us better understand. Is that a dinosaur fossil? Oh wow! This is a historic occasion, the first dinosaur ever to be found in Antarctica. What an incredible discovery! How lucky am I? I can't wait to excavate this so we can describe it 10 years later. All joking aside, unfortunately the fossils they discovered were in pretty rough shape due to the harsh frozen environment in which they were found. This made it difficult for paleontologists to study the weathered material and properly describe these animals. This process could take a while, but let's see what we got. When it comes to classifying ankylosaurs, we need to answer one very important question. Yes or no? Does it have a murder weapon on its tail? Well, I think tail clubs are cool, so I'm gonna go ahead and say yes. But apparently, it's more complicated than that. Aside from just the tail, both of these groups have their own types of teeth and armored plating. Man, this is getting really complicated. Something tells me there's a whole lot more to this whole animal classification thing than I originally thought. I'll just put down other for now. A few decades would pass before finally, in 2021, a study led by Sergio Soto finally asked the tough question: what if, instead of 2 main groups, there were 3 groups? Alright, he didn't just wake up and decide to add a new group, he actually led an effort in describing an entirely new species of Ankylosauria, recently discovered in Chile. Alright, this thing is pretty awesome. Check out that tail. It looks like one of those battle axes used by the Maya. This tail was unlike any other tail seen in the Ankylosaur family tree, and this animal also had a few other unique characteristics. It had a small body, and just like Cryolophosaurus, its skeleton contains a mix of primitive and advanced features found among different species of Ankylosauria. But most importantly to this video, we have to talk about geography. This animal was found in the southern hemisphere where, hey, would you look at that, is also where one of the stars of our video, Antarctopelta, also happened to live. So now we can add a third group to the Ankylosaur family tree called Paraankylosaura, where our friend Antarctopelta is the largest member. Now, here's one of the things that makes science so cool. It's not enough to simply put the pieces together and come up with an idea. Ideas need to be tested and verified. And just this year, a study by Vargas and Caluza, sorry if I mispronounced that, confirmed Soto's findings, and they were able to add another ankylosaur to the group called Patagopelta from Argentina. Okay, so now our friend gets his own special clique to hang out with. What does that have to do with the evolution of dinosaurs? Well, for one, it makes ankylosaur evolution a lot more complex. But it also means that dinosaurs in the southern hemisphere were experiencing different geographical pressures that pushed them in very different directions. For example, our friend Cryolophosaurus. Oh hey there buddy! I was just about to tell everyone about how being in a more isolated environment might have led to you retaining some of your more ancestral traits. Anyways, I bet you're getting pretty hungry. What do growing Cryolophosaurs like to eat? Wait, no, don't eat that one! That's the third dinosaur we want to share with everyone today. Don't worry, I'll make sure you are properly fed. If there's one thing napkins are good at, it's keeping plenty of snacks around. Cryolophosaurus will be just fine. While he's eating, let me introduce you to Glacialosaurus. Glacialosaurus was discovered in the early 90s by paleontologist William Hammer. Just like Cryolophosaurus, the fossils were found in the Hansen Formation, located in the Trans-Arctic mountain range. As you can probably imagine, hunting for fossils in this area is no easy task. It's one of the most remote places on the planet, and the snow and ice makes it difficult to spot grot formations. The whole thing is a logistical nightmare. It's also freezing out here, so once again, the material we're working with isn't in the best shape. Thankfully, paleontologists are used to working with limited material, and based on partial fragments of its legs and jaw, they were able to determine that it belonged to an early species of sauropod morph. Real quick, if anyone is unfamiliar with that term, the word sauropod refers to the long-necked family of dinosaurs. All of these animals are part of an even larger group called sauropod morphs, which includes some of their early ancestors. So if any of you are fans of Littlefoot, Glacialosaurus was related to his great-great-great-great-great-great-grandparents. Now, I drew this one standing on 2 limbs, but by this time, prosauropods were starting to transition to walking on all 4 limbs. So Glacialosaurus was likely able to transition to being bipedal and walking on all 4s. And you might think, neat. Clearly this is a transitional species that bridges those earlier sauropod morphs with the later larger species of sauropods, like Titanosaur. Cool stuff, but ask yourself, why did our friend decide it was time to bulk up? There are several theories around the size explosion seen in dinosaurs during the Jurassic period, the abundance of new plant life, the increase in the amount of predators, environmental factors, all sorts of stuff. However, many of those factors were not present in Antarctica. Compared to the northern hemisphere, the supercontinent of Gondwana contained far fewer larger predators due to the continent becoming more isolated over time. In addition to having less pressure from predators, the southern hemisphere also had a lot less variation with the climate and weather. So, needless to say, several of the factors that we think led to dinosaur giganticism weren't present in the Arctic region. So then, why does my friend here look like he's ready to put on some muscle? Well, just like our original theories on dinosaur growth, it doesn't appear like there's only one reason. However, the dinosaurs in this region had to contend with something that the dinosaurs in the northern hemisphere did not. This. Depending on the area, parts of Antarctica could experience up to 6 months of total darkness during the winter months. Thankfully, it wasn't nearly as cold there as it is today, but still, plants, they kinda sorta like the whole sunlight thing, which means that during the winter months, herbivores would likely have a more difficult time searching for yummy plants to eat. Now, this doesn't sound like the best environment for a dinosaur who's trying to put on some size. After all, how does having less food to eat make you bigger? Well, we have to take a look at what other animals do in similar environments. They slow down a little. An extreme example of this is hibernation, and while we don't have any direct evidence of hibernation in Arctic dinosaurs, we do have evidence that these animals cycled through periods of being active and inactive. Real quick, I want to talk about why we think this. Much like the rings of trees, our bones have lines that show us the growth of an animal throughout the years. There are a few complications with this process, such as overlapping growth periods, but for the purposes of what we're looking at, these periods of large bone growth followed by periods of shorter bone growth suggest that these animals went through periods where they were less active. But what does that have to do with them becoming gigantic? Simple. If you are going to be less active, then you need to do two things. First, you need to decrease the amount of energy you're currently using. Second, you need to make sure you store up enough energy to sustain you through this long period of rest. And do you know what happens when you store more energy? You grow in size. Having more mass lets you store more energy, which in turn helps you survive those long dark winters. But why does that matter? Most of our studies on dinosaurs come from dinosaurs we found in the northern hemisphere. Today, paleontologists are learning more about the diversity of these animals through new discoveries found in different parts of the world. The fact that dinosaurs were able to thrive in areas that were colder and darker than we originally expected opens up new areas for research among different paleontologists. And it also encourages us to reconsider how different factors like climate and geography influence the development of different species. This is one of my favorite areas of research among prehistoric life. As a young monster, I fell in love with the all-stars of the dinosaur lineage, such as T-Rex and Triceratops. But as paleontologists have had the opportunity to discover new species in different regions with different environments, we are learning just how diverse and complex the history of dinosaurs really is. In fact, even in North America, where a lot of our most famous dinosaurs come from, isn't as well studied as you might think. Why is that? It's because the entire continent was split in two by a massive inland sea. On the left, you have Laramidia, where these two lived. And on the right you have, oh wow, would you look at that? Unfortunately, we're out of time. So I guess we'll have to leave the story of the dinosaurs of Appalachia for another video. Until then, I want to thank you all for watching. If you enjoyed this video and want to see more, please consider subscribing to my channel. And don't forget to bring snacks.